Hello everyone and welcome to another video on this channel. In this video we are going to take a look at Azure App Service. I'll just call it a web app, and we will, instead of enabling access to this web app using a public IP, we are going to enable access to this web app using a private IP. Now there's another way to do this with app service environments, but be aware that we are not creating an app service environment here. It's a regular web app that you normally reach by a public name and a public IP. What we'll do with that web app is we'll create a private endpoint for it in our own virtual network. You see that here. And that private endpoint actually creates a NIC, a network interface card, in a subnet of our choice. From the moment you enable private endpoint and private link for your web app, users will not be able to access the web app on that public IP. So we'll go through the creation of the private endpoint, the creation of the networks, the Linux VM, the Bastion host, and so on, and we'll use Bicep to do so. Now, in order to illustrate that creating your own private endpoint is not the only thing you can do, we'll also publish our private web app using Azure Front Door Premium. And I'm using that as an example here of a service that creates its own private endpoint and then links that up to the private web app via private link. Right? So this video does not really focus on Azure Front Door Premium. It's more focused on how you make such a web app private and how does this work with private endpoints. Let's get started. To create the resources, we're going to use Bicep. And if you look in the video description, you will find a link to the repo that contains all the templates you see here. We will actually create a main.bicep or a bicep template that has the target scope set to a subscription. That means we can also create a resource group, and we call the resource group, we use the name of the resource group defined in the parameter here in the default, which is RG web app. Then within that resource group, we're going to create all our resources. Now, I'm not going to discuss in detail the network, the Bastion host, and the VM. But as you can see, they're all modules. For example, the network is created with a module called network.bicep that is in a modules folder, and the scope of that is set to the resource group. So we create the network with subnets, we create the Bastion host within one of the subnets, and then we create the VM as well. So these three modules, they of course create what we've shown earlier, the VNet, right? The default and the Azure Bastion subnet, and then the Linux VM. And of course also the public IP of the Bastion host. Now it's more interesting to look at the web app and the private endpoint and how that is done. That is a little bit more complicated. So let's look at that. To create a web app, I first need an app service plan. So that app service plan is created here. Resource, I'm giving it a symbolic name of web plan. And yeah, it's not called app service plan. It's called at the resource provider level. It's the server farms resource. And at the minimum, that server farms resource needs to know the size of the compute that's behind it. I used the P2 V2 size and name here to indicate that. That's the minimum that I need to create this app service plan. Then we can create a web app on that plan, and we do that here. Again, we create a resource with a symbolic name that I've chosen, web app, and that's the sites resource within the Microsoft.web resource provider. And at a minimum here, again, we need a name, and of course we need to specify the resource ID of the app service plan. You can see that here in the help file or the help hint, the resource ID of the associated app service plan. What that gives us, these two resources, gives us the following thing. It gives us indeed the web plan created in the resource group. It gives us a basic web app within that web plan. And part of this deployment, we will have a public IP, we will have a name for our web app that resolves to that public IP, and we can then reach that web app publicly on the internet. But remember, we don't want that. We want to use a private IP to reach our web app from within our virtual network. The next step will make that happen. Next step is we want to create a private IP address in our virtual network, in a subnet of our virtual network that we can use to reach our web app with. Now, how we do that is we do that with a private endpoint. So I create this private endpoint, in my case, in the same module where I create my web app and my app service plan. It's a resource of type private endpoints, has a symbolic name, has a name, and so on. But more importantly, a private endpoint will result in a network interface. And that network interface has to be created somewhere in a subnet in order to retrieve a IP address from that subnet. I've decided in this case to create that network interface in the default subnet. So in the properties of the private endpoint, the subnet and then ID property, the ID of the default subnet in my VNet should be listed. That will result in the creation of the, well, not really the private endpoint, but the NIC from the private endpoint will be created within that subnet. Now, we are not done yet here, because although we have the private endpoint and a NIC now, we have to tell our web app to use the private endpoint and to stop accepting requests on the public IP. That is done by creating or using private link. So instructing the web app to use a private link to that private endpoint. And we do that from the point of view of the private endpoint creation. So here you can see there's a property which is called private link service connections, which is an array. And in here we specify, okay, this private endpoint, to what kind of service do we link it? So although you saw the arrow in the direction going from the web app to the private endpoint, we actually tell the private endpoint what services that should make use of it, right? So we do that here, and we say indeed, well, we are going to link this private endpoint to the web app, and we use the resource ID of the web app to do so. Now, a service like a web apps or Azure Storage can have some kind of sub-services, right? For example, a storage account has things like we have blob storage and we have file storage and so on. So we need to indicate what type of service we need to connect to. Well, in this case, for a web app, we do that by specifying in the group IDs array the sites parameter here. So that results, if we do this and we deploy this, that results in indeed private link being used by the web app to accept connections via the private IP address that's created by this private endpoint. And at the same time, doing that configuration makes sure you cannot access the web app using the public IP. In order to show the results of the templates I've just shown, I've started the deployment. And of course, this is a subscription level deployment, so we use as deployment sub create for this. Now I'm going to let this running for a couple of minutes and I'll get back to you. All resources are now deployed, and I do mean all resources, also the ones that I didn't discuss yet, such as my front door and the private link.azurewebsites.net that you see there. Now the important part here is my web app or the app service, and that's living of course in the app service plan. So if I click on the web app or the app service, what you'll see is that the app service has a URL, so a name to the web service, and of course there's some IP behind it, but it's all foreseen by the service. Now, because we already enabled private link, we should not be able to reach this website. Let's check it out. And indeed, when I navigate to the public name of that web app, I get error 403 forbidden, and this is the result of the private link and private endpoint configuration that we did. To check if our web app is indeed using the private endpoint that we created, you can go to the web app. Here we are in WebGeba, right? And then we can go to the networking section. There we have the private endpoint connections, and if you click on that, you'll see all the connections to this web app. Now there's one there in a pending state. That's because we already created the front door configuration, and that's something that we'll still need to approve. I'll discuss that in more detail later. The actual private endpoint and private link that I created in the bicep script you've seen up till now is the second one here in the list. So a connection has a name. In this case, it's auto-approved because we're working in the same subscription. And yes, we use the following private endpoint. Now, this private endpoint, as I discussed earlier, uses a NIC, and the NIC has an IP address. So in order to reach our web app using that private IP, what's the private IP that we need to use? Well, you can find that by clicking on the private endpoint. And the private endpoint itself, as I discussed earlier, actually creates a network interface in the subnet that we indicated. So if I click on the network interface, there I can see that indeed the private endpoint and the network interface that was created uses 10.0.1.5. So we must be able to reach our web app using this private IP address. But there's a bit of an issue because we will have to use the name that was assigned to our web app. So if we go back to our web app and we click on Overview here, we'll have to in some way make sure that this name here gets resolved to that private IP. How do we do that? Well, one of the ways of doing it is by using private DNS. So let's take a look how that works. Well, I got you there because we're not ready yet to look at the private DNS stuff in Azure. Let's first take a look on my home PC that uses public DNS servers, what happens when I request the name web-geba azurewebsites.net. And I use the dig tool for that. Well, in the answers section, you can see what happens. Instead of returning a IP address directly, for instance, it shows in something which is a CNAME and then privatelink.azurewebsites.net. Without private link, you would get some other CNAMEs as well, but that's not really that important. The important thing is here that you get this private link CNAME back. This allows us on our private network, for instance, to make sure that we have something at the DNS level that can resolve this to a private IP. Now, in my case, I don't have that. So in the end, this still resolves to this public IP address. And we have already seen that because of private link, I cannot access my web app using that public IP and using that public name. I get a 403 in that case. So let's now take a look what we can do on our own virtual network to make sure that this name actually resolves to the private IP address used by the private endpoint. So what if we create our own DNS zone for privatelink.azurewebsites.net and then make sure, and we can show it again here, then make sure that we create a record in that zone, a web-geba, that returns the private IP instead of, in the end, this public IP. Well, to create such a zone is relatively easy in Azure because there's a resource for that, of private DNS zones type. So here we create this private DNS zone in our resource group, but remember there's not really a location for this. The location is global of this resource, right? So you don't say I'm creating this in East US or something, right? It's a global location. Now it's great that you can create such a private DNS zone, but we have to of course ensure that when a VM on a network somewhere is going to want to use that, we have to attach this DNS zone to our network. And that's what we do with this sub-resource here, a private DNS zone network link, where we link this private DNS zone to a virtual network based on its resource ID, right? So part of the script or the bicep script that was already run creates this zone and links it. We're back in the portal now, and as you can see, the privatelink.azurewebsites.net private DNS zone was created. If I click on that, I can go to the virtual network links, and there you'll see indeed that this DNS zone was linked to my VNet web app virtual network. That also means that if a VM is in that network and uses the Microsoft Azure DNS servers, it will be able to resolve records within this zone, right? Now, what I'm not showing here is the complication of using your own DNS servers instead of Microsoft's DNS servers. That's maybe for another video, but in this case, we just use the Microsoft provided DNS servers for your VNet. Now, if you look at the overview page here, and I minimize the essentials, you can see that there are already some records registered. So WebGeba indeed is going to 10.0.1.5. That's my private endpoint NIC's IP address. And of course, we also need for web apps this SCM name as well. Somehow they got registered automatically. Let's see how that works. In previous steps, you have already seen me create the private endpoint, and it's actually here in the webapp.bicep file. What you haven't seen is that there's also a resource of type private DNS zone groups under that, which is a sub-resource of the private endpoints resource type. I've declared this sub-resource outside of the parent, so that also means that I have to include the parent in the name followed by a slash. So PEWeb refers to the name of the parent resource here. Now, the only thing this does is instruct our private DNS zone to register the records of our private endpoint automatically. So of course, the DNS zone group needs to know what our private DNS zone resource ID is. And we do that here in the private DNS zone configs. We give that config a name, config1, you choose that yourself, and the properties we refer to the resource ID of our DNS zone. That of course means also that Bicep will figure out that the private DNS zone will have to be created first before that the DNS zone ID link here is made. In the portal, this shows up as part of the properties of the private endpoint. You'll see here the DNS configuration, and what you'll see is that we have our config here. So config1 we have over here, and it knows, yeah, indeed, in this case, for a private endpoint that uses a web app, it needs to register the following names here. So this web-geba and this web-geba.scm, both referring to the 1.5 address. That's all it takes for the auto registration of these IP addresses in the private DNS zone. Okay, now it's time to take a look what happens on a VM that's in the VNet that has the private link DNS zone associated with it. I've logged on to my Linux VM using Azure Bastion. And let's see what happens first of all when I run the same command, the dig command that I ran on my local PC at home. So when we do this, we of course get the same CNAME result back. So this CNAME result, but because we can now resolve this because of the Azure private DNS zone to a address of 10.0.1.5, we get the private IP back that was created by the private endpoint. Now we should be able to use, in this case, curl, of course, to access the website. So of course, we have to use this name. There's no way around it. You cannot use another name to access the website. You have to use this name to make sure you get the correct web app from that app service plan. But when we do curl and then -v to also see the HTTP result, you should normally see that indeed we get a 200 OK. That's already much better than a 403, right? And the next thing we can use to check if it's correct, yeah, here we see indeed in the title, we see Microsoft Azure App Service, welcome. So this, well, let's say complicated mumbo jumbo to create a private endpoint that creates a NIC that has a private IP, and then we have this private DNS zone that basically resolves this private link name to that private IP, makes it all work. It's a little bit convoluted if you ask me, but in the end, if you have seen it and you've done this a couple of times, it will become, hopefully, a little bit easier. To drive home the point that private endpoints can not only be used by yourself in your own virtual network, but also by other services, even Microsoft services, to connect to private resources, well, we're going to use Azure Front Door Premium here. So the idea is that we now want to publish our internal web app. Remember, it is still internal. You cannot access it via the public IP. We want to publish it to the internet anyway, but with additional security like web application firewall rules. Well, what Azure Front Door Premium can do, which is in preview today, it can also use a private endpoint. Now, in this case, a private endpoint is not created by you. You cannot even control it. It is created by Azure Front Door Premium, and it's part of a Microsoft subscription, let's say. That also means that if your web app you want to access, or Front Door wants to access your web app using this private endpoint, you will have to approve of this. So an approval step will be created. If you remember, with my previous private endpoint, it was auto-approved when we created the private link configuration. Let's take a look and see how that looks like in the portal first. I'm in Azure Front Door now, and this is Front Door Premium. And I'm in the Endpoint Manager, where I can configure things like what the domains I can use to connect to Azure Front Door, and how does this connect to my origins. And with origins, we mean what are my original websites, resources I want to publish using Front Door. So I have a, let's say, front end, so to speak, just we call it domains here, and that's this one here, AFD blah blah blah, azurefd.net. I also have an origin group defined. I called it very intuitively my origin group. And as you see here, this actually refers to one origin, which is webgeba azurewebsites.net. And if I click in here, we have this ability to use private link service to connect to the origin, the web app, privately over the Microsoft network, right? Now, of course, there's one thing I need to still do. That is to connect this domain name over here to the origin group using a route. So if I click on the route, what you'll see is that indeed this domain, and with this pattern match, we connected up to the origin group. That means that I must be able, or I should be able, to use this URL to access my Azure web app. Let's see if this works. So I'm going to open up a new tab. You will not see parts of this, and I'm going to that domain name that I just copied. That's the Azure Front Door domain name. Now it takes quite a while, so I'm a bit surprised that it takes so long, but actually I'm not that surprised, because I know it's not going to work, because I forgot to do something. I didn't actually approve of the private link. So what this means is that Azure Front Door cannot reach my web app. It cannot reach my web app here, because I have to approve, and you can see that here, approval is required to use Front Door Managed Private Endpoint with the web app. Now, how do I do that? Well, if I go back to my portal here, going back to the portal, and I'm going to my home here, what I can do is I can go to, and that's maybe important to know, I can go to the private link center. And the private link center here is a global overview of all my private endpoints and so on. And what you'll see here is that there might be pending connections. And indeed, I have a pending connection. This is my Azure Front Door trying to connect using private link to my web app. So let's approve this. I click on this here and I do approve. Yeah, there's a description there. Please approve this connection. I click on yes, and the approval starts. And by the way, I can also go to my resource group here, and I can go look at the level of the web app. Let me just minimize the essentials. I go to my web app, and in the web app, if I go to networking, as you have seen before, in networking and private endpoint connections, you can now see that my first one with my VNet is approved, and the other one is in the approving state. It will take a while because he's still busy doing this approval, but when that is finished and I refresh it, then we can continue. So I'll just wait a moment and then get back to you. It took a while for the private endpoint connection to be approved, but that is now done, as you can see in the notifications. And if I refresh this list of private endpoint connections, they now are both approved. That also means that I must be able to now connect to this from the Front Door domain. And here you can see that it worked. I browsed to that domain name that was created by Azure Front Door, and I get my web app here that says, hey, App Service developers, welcome. So this works perfectly using private link. Although we don't provide the details here on how the front door deployment works with Bicep, it is included, of course, in the main Bicep file, and we use a front door Bicep module. That module is coming from the Azure Quick Start templates website, and you can find the link to that in the README file. And as you can see in main Bicep, the front door module takes a couple of parameters. In this case, of course, it takes the resource ID of our app service. It takes the sub-resource, which is sites. And you've seen that we have used that also in our creation of our own private endpoint that we controlled ourselves. But now, of course, Front Door has to create such a private endpoint, and that's why it needs this same information to make all the magic happen. And with that, we have come to the end of this video. I hope you found this useful. If you have questions, please drop them in the comments. And yeah, see you for another video. Bye bye.